So I am recording. It should ask everybody, hey, is this okay? And you'll just have to hit okay. And I want to, first of all, thank you all for coming to this Hearthstone University Speakers Bureau lecture. We've had a wonderful series so far, and I expect no less from Linda. Her reputation precedes her. She was somebody that was recommended to me lots of times, actually, by different people. And I'm just going to introduce her and kind of get out of the way. Linda started her career as an RN, working in the dialysis field and teaching nursing for 24 years. She then switched careers and got her MA in K-12 education. She taught middle school science and social studies for 20 years, which means she'll be very patient with all of your questions, even mine. As part of her curriculum, she taught the history of flight and rocketry and robotics. She's a docent at the Museum of Flight, and she actually just arrived back from doing that. The exploration of Mars has been a great interest, and she was lucky enough to be chosen by NASA to be an education ambassador for the MAVEN mission and trained at the Lawrence Laboratory in Berkeley with the scientists leading this mission. Without further ado, here is Linda Peterson on the history of Mars exploration all the way to our latest rover, Perseverance. And I am going to go dark and mute myself and say thank you, Linda.
Okay, thank you. Nice introduction. Well, welcome everybody. The exploration of Mars is fascinating to me. I hope I can make it as fascinating to you. Mars has been, oh, this is a problem. Get back with my mouse. There we go. Human beings have always been interested in Mars because it shows up as a bright red dot in the sky and is very visible, especially at certain times of the year. The earliest recorded human interest in Mars was found in a tomb built by Senenmut, an Egyptian architect, and it was on the ceiling of the tomb, and it was dated back to 1534 BCE. And here are, I don't know what all the hieroglyphics are, but these are the planets that are visible to the naked eye. This is Mercury, that's Venus, of course, the largest one, and with the pharaoh's crown on, that's Jupiter, and this is Saturn. So Mars should be here. It's not there. Egyptologists believe that this is Mars. It is an empty, rudderless ship off away from everybody else. And that's because in the night sky at certain times of year, Mars looks like it's going backwards. And we'll talk more about that later. But Egyptologists feel like that's why Mars is off to the side like that without a pilot. Now, the ancient Romans and Greeks also were fascinated by astronomy and, of course, had all of their gods and goddesses living on various places. And the Greeks had Ares, their god of war. He was the son of Jupiter and Hera. He didn't like his parents much, according to the Iliad and the Odyssey. And the Greeks kind of treated him as kind of a cowardly person. He wasn't a favorite god, but he did have two sons with his wife Aphrodite, and they were Deimos and Phobos. Deimos means destruction or demolish. That's where we get the word demolish. And Phobos means fear, where we get the word phobia. And the Romans, of course, adopted all of the Greek gods and renamed them. And they renamed Ares Mars. And the Roman name stuck with the planets. And the two human-like figures of Deimos and Phobos were turned into war dogs. And these war dogs accompanied Mars wherever he went to war. So you'll see in Greek mythology that Deimos and Phobos are human in appearance, and in Roman, they are dogs. Now, why is Deimos and why are Phobos important? Well, that's the name of the moons of Mars. Now, the first early telescopic explorers, we all know Galileo. He built the first working telescope, and he actually wrote about what he saw on Mars. And then around the same time, 1659, Christian Huygens, a Dutch astronomer, actually built his own telescope, and he drew pictures of Mars. I love this one because it shows the polar ice cap. So he could, even back in 1659, he was able to see the polar ice cap. And these are modern pictures of Mars, and you can see he got the shapes pretty accurately. Now, in the 1800s, Giovanni Schiaparelli mapped the light and dark areas of Mars that he could see. There again is the polar ice cap. And he drew all these, what he called canales, and it was straight lines. And then Percival Lowell mapped hundreds of these channels. He called them channels. And he wrote a book called Mars. And this is plate 5 from his book. And he had the latitude and longitude of Mars there. And he was convinced that intelligent beings had built these channels, whether they were channels for water or roads. And he was so convincing in his book that it inspired H.G. Wells to write War of the Worlds. So here you go, Carol. Why Mars? Well, NASA's goals are to study the history and geological and climate processes that have shaped Mars into the planet it is today, and to see if there was potential for Mars to have once hosted life, and to plan for future explorations of Mars by humans, and importantly too, to compare and contrast Earth and Mars. Some of the geology we're finding out is almost identical. And with the atmospheric changes on Mars, could that happen on Earth? The other reason is Mars is close to Earth. It takes 3 days to get to the moon. It takes 9 months to get to Mars. It takes 15 years to get to Pluto. So Mars is a nice close by place to visit. Mercury's too hot. Venus is too acidic. It eats things up as it goes into, if any probes go into the atmosphere in Venus, they tend to disintegrate. So I'm going to give you a few facts about Mars. You may remember from high school science, but it is the 4th planet from the sun. It sits between Earth and the asteroid belt that's between Mars and Jupiter. Now, Earth is about twice the size of Mars. And of course, the moon is much smaller. The thing that's important about that is, as we're talking about the planets and landing on them and walking on them, is gravity. Now, gravity is based on how big an object is, how much mass there is. So Earth has way more gravity than Mars, and way more gravity than the moon. And if you remember watching the astronauts on the moon hopping around, it's because there's like 1/6 gravity on the moon than there is on Earth. So it's easier to hop around. Oh, and by the way, today is the anniversary of the Apollo 11 moon landing back in 1969. Just a little tidbit there. So, okay, come on. All right, why isn't there we go. So there's the gravity. You will weigh about 1/3 less on Mars as you do on Earth. Your clothes will still be the same size, but the scale is much kinder on Mars. Now, Mars is a long way away from the sun. We are 93 million miles away. That is 1 astronomic unit. Mars is 1.5 astronomic units. So its year is twice as long as the Earth's, which means they have seasons just like the Earth, because it is also a tilted planet. And so its winter is 6 months, its summer is 6 months. The days on Mars are the same length as the days here on Earth. You can see Earth is traveling around a lot faster. Now, I showed you that Egyptian picture with Mars over to the side because it's retrograde appearance. Now that's important to think about when we're thinking about launches. Now, does Mars really go backwards? No. Think about driving on the freeway and you pass a vehicle and it looks like that vehicle is going backwards behind you as you're passing it. Well, that's what happens with Mars. So here's Earth orbit, here's Mars orbit. Now I'm going to let you watch it first, and then I'm going to explain how we plan launches to Mars. Okay, right there where they meet, this straight line where the convergence is there, that is our closest point to Mars. But we can't launch there. If we launch here to get to the closest, Mars will already be over here because it's 9 months later. So we launch around here and then meet Mars here because it is a 9-month window. And that 9-month window only happens every 2 years. So if they have to scrub a Mars mission, they have to wait 2 years before they can launch again. Now, Mars and Earth both have layers, but Mars cooled off much more rapidly than the Earth. So the interior is a bit different. Think of baked potatoes. A big baked potato retains its internal heat much longer than a small baked potato. Well, that's what happened to Mars, and that's going to become important later when we talk about atmosphere. But Earth has an extra layer, and our nickel interior gives us magnetism on Earth. Now, the other thing that's important about landing on Mars and breathing on Mars is the atmosphere. Earth has over 100 times more particles in the atmosphere than Mars does. The Mars atmosphere is very thin. Also, Earth is mostly nitrogen and oxygen. Carbon dioxide is almost the entire gas on Mars. If anybody has any questions, feel free to unmute yourself and interrupt me. That won't bother me a bit. I'm used to teaching 6th graders. Okay, now to get to the missions. Any questions about Mars as a planet? Okay, so there were 10 Mariner missions altogether. Mariner 1 and 2 went to Venus. 3 and 4 and some of the later ones went to Mars and other planets. I'm not going to talk about all 10. Mariner 3 and 4 were launched in 1964. Mariner 3 was lost on launch, but Mariner 4 did a flyby. Just means it didn't orbit, it just flew by and took pictures. And here's one of the first pictures ever taken of the Mars surface from Mariner 4. Pretty grainy, pretty primitive, but you can see some of the craters on Mars. Mariner 9 actually became an artificial satellite. It actually orbited Mars and it photographed and mapped 100% of the planet. It also photographed the 2 moons, Deimos and Phobos. And you can see it's powered by solar panels. So here's some pictures. They are better now from Mariner 9. This is a mosaic. They took thousands of pictures and a computer put them together into a cohesive picture of Mars. This is the northern polar ice cap. Now this is one of my favorite features. It's the Olympus Mons. It's the largest volcano in the solar system. It's extinct, but it is 88,500 feet tall or 14 miles. It's in 300 miles in diameter. It's a shield volcano, meaning it's built up by lava flowing off of it. Everest is only 29,000 feet. It's just a baby compared to Olympus Mons. I did want to show you a modern picture of Mars. This is the Olympus Mons right there. These are 3 other smaller volcanoes. They're all dormant. or extinct on Mars. This, for such a small planet, Mars has a lot of big features. This is the Valles Marineris. It's the Grand Canyon of Mars. However, it's 2,500 miles long, the width of the United States, and is 4 miles deep. Our Grand Canyon is only 277 miles long, and it's only 6,000 feet deep. And there are Deimos and Phobos. This is Deimos, and that's Phobos. They are captured asteroids. They're not like our moon. They're not round and spherical. As I told you before, Mars is sitting next to the asteroid belt, and it captured these two asteroids in its gravitational field. If any of you have watched the Star Wars movies, if you notice this shape of Deimos, that's what the Death Star was patterned after. Okay, the Viking landers, 1976 to 1980s, we finally land something on the planet, and it looks very different from what we have today, but it didn't move. It just, the two of them were stationary, and they were on other parts of the planet. They didn't land near each other. And here is a picture taken from one of the Vikings, and they were searching for microorganisms and none were found. The conditions of Mars, on Mars' surface, are somewhat self-sterilizing. Now, whether there's something subsurface, they don't know yet. But the temperature ranges on Mars go from minus 200 degrees Fahrenheit up to 70 degrees during the summers on the equator. The average temperature is minus 80 degrees, so not a very friendly planet. Pathfinder, the baby rover. Now, this is an artist's rendition of what the lander looked like once the airbags deflated. Now, all the other things, the ones we just saw, the Vikings went down with parachutes only. With this, because it had the rover and was heavier, they decided to use parachutes, and then they deployed these airbags. And that was a very nerve-wracking thing for NASA, because this lander bounced for quite a little while before it came to rest. And those airbags had to withstand the temperature on the surface as well as all the sharp rocks, but it worked. So once it landed, these solar panels were deployed and the track for the surveyor to come off. Now, this is about as big as a microwave oven, just for comparison's sake. And right here, you can see it's drilling into a rock. This picture was taken by the lander. Now, the lander actually had a name, the Carl Sagan Memorial Station, and the rover was Sojourner, named after Sojourner Truth. It was never more than 40 feet from the lander and never went more than 330 feet in the 3 months it was working. But it made some important discoveries in the geology of the rocks that showed that Mars was a warm, wet planet at one time. The lander sent back 16,000 images and the rover 550. They also did chemical analysis of the soil and the rocks, and that's how they found evidence of water. Now, Mars Odyssey is the longest lasting mission of NASA. It was launched in 2001. It is still working. The Odyssey was to make the first global map of chemical elements and minerals on the surface. And that took place between 2002 and 2004. And they did that with spectrography. They had special cameras that could pick up light reflection off of the surface and analyze what molecules were in that surface material. It also identified areas of buried ice. There is buried ice on Mars, particularly up at the polar surface. For a long time, they thought it was frozen carbon dioxide, but it is frozen water as well. It also measuring surface temperature at different latitudes. And a very important finding for human exploration is that the low orbit radiation of Mars is twice as strong as Earth's low orbit radiation. So astronauts on Mars are going to have more protection because of the radiation. Odyssey today provides communication links for all the rovers, and when they're ready to make a launch, they send Odyssey out to take pictures of landing sites to see if there's still a possibility. Mars's surface changes because they do have windstorms, and things do move around on Mars, unlike the moon where there isn't any wind or erosion, so it stays pretty much the same unless a meteor hits it. Here's just a couple other of the satellites that are used by NASA. The Global Surveyor is no longer functional, but the Mars Reconnaissance Orbiter is still providing pictures and information about atmosphere and weather, as well as providing links for the rovers. My favorite orbiter, the MAVEN. It was launched in 2013 and it's still in operation. There I am at the launch. There's the rocket way over there. They make you stand 6 miles away. It's still unbelievably loud. And this is a picture taken with a telephoto lens of MAVEN. The satellite is actually up here in the nose cone. These poor birds don't like the noise, but they always come back to the lagoon. These 4 towers that you see on launches, they are actually like lightning rods. They act like what's called a Faraday cage. It keeps electricity away from the rockets. So the launch, you see another launch pad over here. There's the lightning rods. These are the buildings where they assemble the rockets. So MAVEN stands for Mars Atmospheric and Volatile Evolution. And it was the first mission to be in their low-cost program called Mars Scout. And they were making low-cost satellites and using principal investigators from universities for the first time, rather than just NASA and JPL folks. And why did Mars lose its atmosphere and become a dead planet? Well, I talked about the magnetism in the core. That's the important part. This is Earth, and we have a magnetosphere. Because our core is magnetic, it surrounds the planet with a magnetic field. Now, you've all used magnets, and you put like poles together, they repel. You put opposite poles together, they attract. This magnetic field repels cosmic radiation coming off the sun, except at the poles. And that's why we have the auroras. The cosmic particles get down into the poles and our atmospheric molecules start moving around faster and giving off different colors of light. And that's why we have the auroras at the poles. Sometimes the cosmic rays are so strong, we can see the auroras even down this far. Now, this is poor Mars. These little dots, that's what's left of its magnetic field. It didn't develop a really good magnetic field because it cooled off too fast, and the core did not develop magnetism over the whole planet. Now I'm going to show you this video, there's no sound with it, of a coronal mass ejection. That's what these are called. Those are the rays we used to put out on our sun pictures when we were little children. So these come off the Earth, sometimes off the sun. Sometimes the sun is more active than others. So I'm going to start this. And those are actual particles. This is coming from one of the heliotropic satellites, but the rest of it's animation. So this is Mars, and it's repelling some of it, but not all. And you can see that the atmosphere of Mars is being pulled off by what's called the solar wind, and off it goes into space. With Earth, that doesn't happen because it's most of those, we get some cosmic rays. But this, I'm going to pause this right here. These are the leftover little magnetic fields on Mars. And what's fascinating is that the Mars satellites that we have up there have seen auroras on all these little places. They get little auroras around them where the cosmic rays are getting in. But all of this part of the planet that doesn't have any magnetism, the atmosphere was stripped off. Any questions about that? The other thing about MAVEN that's really fun for me and some of my previous students from back then, they still email me, is MAVEN still circulating Mars? Because there's a disk on there that has all my students' names on it. It's on the satellite. And so my students' names are rotating around Mars. And they think that's pretty fun. So here are the twins, Spirit and Opportunity. They were built to last 90 days. And they were sent to opposite sides of the planet to again do geological features and test the atmosphere. They both found evidence of past water effects in the soil and rocks. The thing that was fascinating is Spirit landed in 2003 and worked until 2010. It had a bad wheel and they had to drive it backwards for a while so it would get stuck in the dust. But finally it couldn't turn around, so its solar panels were facing away from the sun and the battery died. Opportunity landed in 2004 and it lasted till 2019. And in the winter, there was so much dust on the solar panels, it couldn't recharge its batteries. It wasn't getting enough sunlight. So it too, we lost that one too, but not bad for something that was built for 90 days. Little over engineering, I think. But they were very effective at seeing effects of water channels and effects of water chemical changes in rocks. Now, Curiosity has really shown us the evidence of water. This again is a rendering from an artist, but the wheels are much different. This is as big as a car. This is a very large rover. And you can see its arm here. And when we get to Perseverance, you'll see the arm has been much improved. It is still operating. It was launched in 2012. And it is the largest, most capable rover. And it descended with a parachute, but retro rockets. And that was different. They'd never used retro rockets before. A retro rocket is on the bottom of the vehicle and it goes down. And that allowed it to hover. And then it opened a hatch at the bottom and the rover, Curiosity, was actually on cables and it lowered it to the surface, released it, and then the landing system flew away and crash landed a safe distance away. Curiosity travels 100 feet per hour and can climb over knee-high obstacles. So they really made it much more maneuverable. And the thing I find fascinating about these rovers is they're being driven down at JPL in California. Somebody who's really good at video games is driving these things on Mars. It also is not using solar panels. It's using nuclear energy. It's got a plutonium decay device, and that is what's providing the power. And it was supposed to last for a year, but again, it's still working and working well. And it actually takes samples using a laser that goes to the rock. The laser pinpoints drilling and makes dust and brings it back into the actual rover that has several lab equipment modules on it. And it actually does chemical evaluation right there on Mars and then sends the information back to JPL. That arm is 7 feet long. And as I say, it's still in operation. One of the most exciting findings of Curiosity was the finding of hematite. If you ever read about this mission, they talked about blueberries on Mars. That's what they were talking about. This is hematite found on Earth. Hematite on Earth is only formed near water or in water. And they feel that that's the same on Mars. So there had to be water. There are great fields of hematite on Mars. And it is ferrous oxide, iron oxide. And when iron is exposed to oxygen, it turns into rust. Rust is orange red. That's why Mars is orange red. It's all the eroded hematite. So basically, Mars is rusty. And some of you may know about hematite. It's used here for people use it as magnets. They use it, they wear bracelets. They feel hematite has healing powers. So you'll see hematite all over the place here. But this was a very exciting, yes, Mars was a wet planet. Still haven't found any signs of life yet. So here's our latest and greatest, the Perseverance. It landed in February of this year. COVID couldn't keep our landers on the ground. They still got to go up. And you'll see the arm here is much more elaborate than Curiosity. And that's because this is a bigger drill. It is a core drill. It's actually taking core samples from Mars. And it's looking into astrobiology. Is there evidence of microbes below the surface? Even though there's none on the surface, is there some below the surface? The other part of the mission is, can a helicopter fly on Mars? If you remember back to a few slides ago, Mars has a very thin atmosphere. For a plane or helicopter to fly, they need to have enough air underneath the wings or the rotors to create lift. If there isn't much air, it's hard to create lift. So they didn't know for sure whether something would fly on Mars. And having a helicopter or some sort of air delivery, once humans are there exploring, would make things much faster to deliver rather than having to use a rover or like a moon buggy that we had on the moon. So this was an important experiment. The core sample is interesting. They're pulling up these core samples and leaving them on the surface. And then another mission in the future is going to Mars, picking up those core samples and bringing them back to Earth for analysis. That's in the future. Another important experiment that Perseverance did was, can oxygen be manufactured on Mars out of their carbon dioxide atmosphere? Yeah, in April, the oxygen extractor on Perseverance split out carbon and oxygen, was able to create oxygen. That's important for future space travel up there, because if you think about how much fuel you need to get to Mars, do you want to be taking all the oxygen for the 2 years they're going to be up there? Do you need all the rocket fuel, water, all sorts of things? You can't have a rocket big enough at this point. So they want to look at what can we manufacture out of the raw material on Mars. And is there subsurface water? We know that there's frozen water at the poles. Water's important. We need water to drink, but also we can also manufacture oxygen from water and split out the hydrogen, and that hydrogen can be used as rocket fuel for the return trip back to Earth. So all of these environmental factors will affect human exploration later on. And we're working on human exploration of Mars right now. The rocket that's going to Mars has already been built and tested. It's called the Orion. And I didn't put that in here because that's a future talk. So I want to show you Integrity. That's the little helicopter. It does have a solar panel. Again, Perseverance is using nuclear fuel. And I was able to get the helicopter actually flying on Mars. I'll show you this video. It's from JPL, so it has captions, and it also has sound. You can hear the wind on Mars because the camera on Perseverance captures sound. And if you listen carefully, Integrity will have a circle around it. I put a circle around it. It's going to be over here. And once the rotors start going and it's lifting off, you will hear a different hum. That hum is the sound of the rotors on the helicopter. I don't know about you, but being the space geek that I am, I found this very exciting. Oops, let me go back. Okay, there we go. I hope you can all hear that. There it is, taking off. And you can hear the helicopter as it's coming back. So I just find it amazing that in 1903 was the first controlled flight by the Wright brothers. And here we are watching the flight of a helicopter that we built on another planet. It doesn't, wasn't that long ago that we had the first controlled flight. So some resources for you before I get to questions. If you want to know more about Mars specifically, you can go to mars.nasa.gov. And if you want to see those where I got those pictures and you click on the pictures, you get a lot of information. It put \Mars-exploration, but just nasa.gov. I highly recommend if you've got time on your hands, you could lose yourself for days on that website. A really good, interesting book about the spirit and opportunity is called Roving Mars by Stephen Squares. He was the head of that project, and he wrote a very readable book about how they go from the very beginning of proposing a mission to actually running the mission. There's a lot of politics involved in getting the money. There's also a good, on Discovery Channel, probably YouTube now, Roving Mars was made into a documentary as well, and that was really good. This one isn't necessarily about space exploration, other than spaceweather.com is really about Earth and how space weather affects Earth. It will say, if you subscribe to it, they will send you emails when an aurora is going to be available at our latitude. They will tell you when asteroids are coming close by. Sometimes you don't want to know that. Some of them come pretty darn close. They also talk about coronal mass ejections from the sun. And the only reason we worry about that is if it is a large enough ejection, it can affect all of our electronics, including electricity. The satellite, it can wipe out satellites above our atmosphere. Our atmosphere does protect us somewhat, but not if it's a large ejection. So they back in, I can't remember the date, but there was a large coronal mass ejection, and it basically wiped out all the electricity on the East Coast. So that does make a difference. And you'll see a lot about that on the NASA site as well. So if you have any questions at all, I'm going to stop sharing, and you can unmute yourselves and ask me any questions you may have.
Well, I'm going to ask you what made you personally get interested in this in the first place?
Well, in second grade, I read The Mushroom Planet and the Return to the Mushroom Planet, which is a science fiction book. And that started me on the road to being absolutely addicted to science fiction. But I really got interested in space flight back when I watched the Apollo missions. I was in a junior in high school when they did the first landing. And I've just always been interested in stars and astronomy ever since I can remember. And then when I started teaching middle school science, some of the science curriculum they had in our district was like watching paint dry. So I developed my own curriculum, given that we had Boeing and Blue Origin and all these things in the area. I did a curriculum that the district then adopted on space and aerospace and rocketry, and then I added robotics. And they had to, my students had to make Mars rovers. And I was NASA, and they had to sell them to me. They had to program them and build them out of Legos. And yeah, so that's how I got interested. And then I've been with the Museum of Flight as a volunteer for 24 years. So I took my students there. So yeah, so that's how I got interested.
Okay.
Oh, you're muted, Bob. Mary?
There we go. There we go. Okay. I'm curious about the money.
So's NASA. Where's the money?
Follow the money.
Yeah.
Where, well, or maybe you could give a financial figure for the launch, the design, development, and launch of Perseverance, the last one. And then perhaps tell us where that money is coming from.
Pay your taxes.
Okay.
NASA is tax supported. They have to go to Congress to get money. They have to be approved by Congress. And that's where most of these have come from. Let me just look up Perseverance for you, because I don't have the exact number. And there's a lot of people who feel that, why are we spending money? It was $2.2 billion.
Okay.
To develop it, launch it, and be running it. And that's a lot of money. But the things we're finding out by doing space exploration, especially the experiments they're doing on the International Space Station, we're getting medical things up there, agricultural information. There's a lot that if you use Velcro, you can thank NASA. So that we get a lot out of it, but with all the problems on Earth, you think, oh, should we be spending the money to do that? I'm of a mind that yes, we should, just because human beings are explorers. And what we're doing with global warming and what we're doing to our atmosphere, what's happening with Mars atmosphere, could that happen to us? If
Yes.
our magnetic sphere does change.
Mm-hmm.
And so what the information we're getting, now that we're getting into these big droughts, Mars is a planet of drought. So we're getting a lot of really good information, I think, for our dollar. And now with the privatization of rocketry, now that Jeff Bezos has come back unscathed, and he took Wally Funk. Anybody know who Wally Funk is? She was one of the Mercury female astronauts. And because we females are so delicate, NASA let the females go up into space until Sally Ride. So she was one of those selected. She was one of the first female astronauts in the United States. And she finally got to space with Jeff Bezos at 82 years old. So
When?
part.
Yeah.
So it's always changing what's going on. And so I just find it fascinating. Does that answer your question, Mary?
Yes, it does. And the second part of the question is a lot of companies benefit from what NASA discovers.
Yes.
And so how do they recompense NASA and the government for the rights to use this information, or do they?
They don't, because it's all public domain.
Oh,
I mean,
rats.
all these pictures and things I've got are public domain from NASA.
Okay,
Yeah. So it's our tax dollars, basically.
okay.
I'd like to just make a comment. This is Ruth over in Lakeside.
Oh, hi.
Hi. I don't think my camera's on. There we are.
Yeah, there you are, Ruth. I've seen you before.
Hi. I just wanted to tell everybody that there is a documentary that's very good about the Mercury 13, the
Mhm.
13 women that trained to be astronauts, and it's called Mercury 13.
Yeah, that's really worth watching. It's really good. Yeah. Yeah, women did a whole lot, like all the mathematics to get things up into space done by women. Yeah, we're finally getting some recognition at NASA. Any other questions or comments?
I'm curious, when you went to view the launch, were you given a designated spot to watch from? And did you have to have permission to be in the vicinity? How did all that work?
Well, after being trained at the Lawrence Lab, we worked with the actual scientists, and Bruce was a great teacher, being able to teach us this physics that's up here. They then invited, there was 10 teachers, one for each NASA region in the United States, and they brought us all out to watch Maven being launched.
Okay.
And it was amazing how we teachers were treated. It was like, oh, they're feeding us real meals and putting us up in really nice places. And we got to spend the day at the Kennedy Space Center, as my husband calls it, Disneyland for space geeks. And then we were taken to the launch site. We were getting a tour of all those buildings. And then the next day we were bused out to the viewing site, which you had to have a special pass to get there. And their bleachers set up, and we're literally 6 miles away from the actual launch, because if something blows up, they didn't want us hit by the shrapnel. And you could see very well. It's very bright and very loud. I mean, you can feel it in your chest, the sound. So yeah, it was really nice. They just treated us, and they had a class. It was at the Space Center, so it was more than just us there, but a lot of people there talking about Maven and what it was. And one of the speakers was Bill Nye the Science Guy. And I started laughing, because I'm thinking, oh, I'm listening to a comedian tell me about something I've just been learning about for 4 months. And one of the teachers next to me said, why are you chuckling? I said, it's Bill Nye the Science Guy. Well, yeah, he's really good. I said, oh, I know he is. But he started out as a comedian in Seattle. So yeah, so it was really, really, I had to apply to the ambassador program. There's a long application process that you go through first, and then you're accepted and do special training.
Linda,
Oh, go ahead.
I'm waiting. Go ahead.
Oh,
Ruth?
I have a question. Is anybody talking about sending our waste to Mars or the moon? We've got all this nuclear stuff that we just can't do anything with.
Yeah. Yeah, maybe they can recycle it somehow into fuel. I'm sure it's, I don't know that. But I don't know what they're gonna do with the spent fuel. Yeah, spent fuel. I don't know.
Linda, I have a question for you. This is Steve.
Hi, Steve.
Thank you so much. This is just an amazing presentation.
Oh, thank you.
One of the things that we keep hearing about is sending a man to Mars.
Right.
I'm impressed with how much information we can get by sending these machines there without risking human life.
Exactly.
And I wonder what if there's a sense within the NASA community about how important it is to send a human being there, or human beings with obviously a huge, I mean, the expense of that would dwarf what's being spent right now. Do you have any thoughts or insights into that?
Part of it is the speed. Oh, I'm getting Steve, I'm getting an echo. Okay, now it's fine. No, somebody else has two things on because I'm getting an echo. It might be me. Let me check. Okay. Human beings want to explore. There's only so much a rover can do. They want to explore planets just because that's what we do. But how do human beings survive in a hostile environment? And one of the places they train is in Antarctica because it's cold, desolate, but that's part of it. And I think the thinking is people will be more excited and want to spend more money if it's actual human being going up. That's one of the thoughts. Now, what the powers that be at NASA are really thinking, I'm not privy to, but I know that when we were talking about it, when I was down there in 2013, that was some of the thinking that people like to explore. Why did we send somebody to the moon? There's nothing on the moon. And the moon is not even interesting rock because it's basically a piece of the earth. It's the same rock. But just having human beings on a different place is exciting. So I think that's part of the thinking, Steve. Carol, you had a question? You're unmute, yeah.
Be sure to send somebody who can grow potatoes.
Yeah, yeah, they grow potatoes on Mars. You read that same book or saw the movie.
Hey, does JPL, Jet Propulsion Lab, play a part in this
Oh
program?
yeah, NASA and JPL work together on most missions.
Okay.
Yeah, JPL's in California.
Yeah, no, I know JPL.
Mhm.
I just didn't realize that Berkeley, that lab in Berkeley was involved too.
Yeah, the Lawrence lab is a national lab. And you have to,
Okay.
that was really funny. I had to get security clearance to go there. And, you know, we'd point out things and say, you can't talk about that. We'll have to shoot you.
Well, I think Frank worked there. Didn't you work there?
Yeah.
Frank
Oh, did
worked
you
there
work
at a few
Up on
summers.
top of the hill. Yeah. Yeah, it's fascinating opportunity. I was so lucky.
Yeah, that's great.
Yeah. Any other questions? Okay.
I have a question about, so all of the things that we're launching to Mars
Mhm.
remain there as space junk.
Yes. Yeah, we have 17 tons of space junk on the moon.
Wow.
That's alarming.
Yeah, we're polluting outer space almost as well as we're polluting our own planet. No, the stuff is just left there. Yeah, it's too
Is-
expensive to bring it back.
So could I say something here?
Sure.
Am I unmuted?
Yes, you're
Yeah.
unmuted.
I would like to say this is a fascinating presentation. I went from kindergarten at least to the third grade, knowing about Mars, and it was you were so clear, and it was just a privilege. I felt like my time was honored, and I really learned a lot. Thank you.
Yes, it was
Thank you so
wonderful.
much.
Yeah, it was great, Linda. Thank
Oh,
you.
thank you so much. I sure appreciate that.
Yes,
Linda,
thank you.
what day are you
Yeah.
at the Museum of Flight? What day do you work?
My regular shifts are the first and third Tuesdays of the month in the morning. So
Okay,
I'm there from 9:30 to 1:30, the first and third Tuesdays. That's my docent shift. I also do other shifts for special projects, but that's my regular shift.
thank you.
You're welcome. So if you're ever there, I'll give you your own personal tour.
I was thinking of
Thank
bringing
you.
our granddaughter.
Oh, do.
Oh,
That'd be
that's a good
great.
idea. Yeah.
Yeah.
I was just talking about that too.
Yeah.
Does anybody have any other questions? Because I have one final thought,
Okay.
which might be annoying.
Oh, I love it. You can defend your sixth grader.
I've got a sixth grader, and believe me,
There you go. You
I
know,
understand what you're saying. So I watched a great documentary that has nothing to do with space exploration, but it's set in 1969. It's about the Harlem Music Festival, and that was a really hot topic right now at that time. And so many people in the audience that didn't know about it were saying, why are we spending all this money sending people to the moon? So I want you, please, if you could, make us mini ambassadors and give us a sentence or two to say, why do we support the space program?
yeah, I would just answer that for Mary, but I'll answer it again in a shorter version. It's what we're finding out that'll help us here on Earth. What we found out, the International Space Station is a great example. We're spending a lot of money on that. We are using private rockets now to supply it, but some medication, diseases, how we're treating certain things has changed based on what they have found on ISS. The moon would be a great launching point, a staging point for going to places like Mars and other planets, because it doesn't have much gravity. It's got maybe a sixth of the gravity of Earth, so you need less rocket fuel. Just the geology that we've learned, the geology on other planets will tell us about our own geology, and our geology tells us about other planets. For example, until the moon rock came back, and by the way, there's a great moon rock in the Apollo exhibit at the Museum of Flight, we found that the moon is a chunk of the Earth. At some point during the early solar system, when everything was coalescing, a huge asteroid or mini planet or something hit the Earth, and a big chunk of it flew off, coalesced, and became our moon. Because the rocks, it has the same composition as the Earth. So we find a lot out.
It helps us.
On Mars, we're finding out what happens when a planet loses its atmosphere.
Yeah.
Could that happen here on Earth?
Oh,
Yeah, we're losing water. I just was listening to a program about the Southwest, that they're running out of water.
Yes.
They tried to terraform a desert in Vegas,
Right.
and they're running out of water. They're now
Oh my
not allowing people to plant grass. So we're losing water. What happens?
Right.
Yeah. So it's important to spend that money, I think.
Yeah. Oh, I agree. I was just looking for a brief way to say that to others who maybe don't know as much as you do. And I
Well,
think you've given us some.
Yeah, my daughter and I argue about this all the time. She works with the homeless. And she says, we're spending all this money. Jeff Bezos is going up in space instead of building housing for the
Yes.
poor. And I agree
Yeah.
with that too. Can we do both? There's enough money. We can do both if we have the willingness to do it.
I agree with you there, but that's a whole nother topic.
All different talk.
But I want to say thank you, Linda. It was really
Yeah.
fascinating. I was able to listen to most of it, and I appreciate your knowledge, and I appreciate everyone's questions.
Yeah.
And I mean, this is going to be great for our TV channel. You know, hello, viewers of the future. I say that every time because I'm that corny. And I promise no more bad David Bowie jokes, but I will say thank you.
Yes.
And,
Welcome. Thank you, everybody, and see you all at dinner.
This is a fabulous, fabulous presentation. Wow.
Thanks. It was fun to put together.
Yeah.
You did it so beautifully.
Oh, thanks. Thanks. It was fun. I enjoyed it.
You're
Bye,
born
bye, all.
teacher.
Get on with your day.
Okay.
Okay,
Bye-bye.
goodbye.